All right, this is a video on point-slope form of a linear equation, and we will start with an introduction and then do a couple examples. So point-slope form is one of the three forms we'll be talking about, all of which represent linear equations, and they all have their pros and cons and advantages and disadvantages, okay? So let me give you point-slope form right here. Okay, y minus y1 equals m times x minus x1. And the slope is m, and a particular point that the line goes through is x1 comma y1. So in actual practice, when you write out point slope form of an equation, these things I'm highlighting in yellow will all be actual numbers. Those are the coefficients in your equation. And then of course x and y will stay as variables. So as a particular example, let's say you have an equation like this: y plus 3 equals 5 halves times x minus 2. All right, so think about like what point does this go through, what slope does the line have. So I hope you can see the slope is 5 halves. And I hope you can see that a point it goes through is 2 comma negative 3. And the reason it's a 2 and a negative 3 is because over here you can see that point slope form always has a subtraction in there. Okay, so I'm going to rewrite this equation as y minus a negative 3 equals 5 halves times x minus a 2. Okay, and so we've forced there to be a subtraction in there, and then we can confirm that the points are 2 and negative 3. Okay? So that's just an example of point-slope form. So we can write an equation in point-slope form. Just use the same format, y minus y1. So it looks like this is x1 and y1. So negative 4 is 2/3 times x minus x1, a 3. And honestly, people are probably going to want to simplify this to y plus 4 is 2/3 times x minus 3. So I said we need to force there to be a subtraction in there earlier. That doesn't mean in its simple form of writing that there necessarily needs to be a subtraction. But y plus 4 is equivalent to y subtracting of a negative 4. Okay, so that would be our example right there. Next one, you might have 2 points and you're trying to find point-slope form. So let's find slope first, and then we'll plug it into point-slope form. So m is always going to be a subtraction of the y's divided by a subtraction of the x's. Don't try to do too much in your head, just write it down and let your calculator do the math if you're getting overwhelmed here. This is a 15 up top, negative 1 minus 4 is negative 5, so we get a slope of negative 3. Okay, so cool. So we have a slope. Now we need a point. It doesn't matter which point you pick. So I'm just going to arbitrarily pick the first point and pick that slope and plug everything into point slope form. So y minus our y value equals our slope times x minus our x value. And then it's a little cleaner, like I was saying earlier, to write that as x plus 1 instead of subtracting a negative. Okay, so that's an example of taking 2 points and finding point-slope form. Let's graph an equation here as well. So I think it's best practice here to actually write out what you know. So I know that my slope here is negative 2/3, and I know that my point is a 4 comma negative 1. Okay, so once again, I turn the y plus 1 into a y minus a negative 1. So let's plot that point, 4 comma negative 1, right there. And we need a slope of negative 2/3. So down 2 over 3, down 2 over 3. We can go in the opposite direction as well. So up 2 over 3 to the left, up 2 over 3 to the left. And it looks like we have a pretty clean line we can draw in, try to make it nice and neat. Okay. And one thing I think maybe you're realizing, I don't know, is that point-slope form doesn't give us the y-intercept. So the y-intercept here looks like it's about 1.5. To actually find the y-intercept, you would need to, I know I didn't ask you this in this problem, but you would need to plug in 0 for x and solve for y. Okay, so you would go through that whole process, plugging in 0 for x. Let's actually finish it. Negative 2/3 times a negative 4. Y plus 1 equals 8/3. Subtract 1 from both sides. Y equals 5/3. Okay, so that number is, that y-intercept is 5/3. So it looks like my graph might be a tiny bit off there, but not too bad. Okay, so that's one of the biggest drawbacks of point-slope form is difficulty in finding the y-intercept. You can convert between forms as well, and you can convert between point-slope and slope-intercept forms. So if we have slope-intercept form and you want to go into point-slope form, that's probably not done terribly commonly, but let's do it. Let's just pick an x value, okay? Let's pick an x. I'm going to pick -5. Okay? Doesn't matter. Pick an x. Let's solve for y. Okay? So y equals 3 times -5 minus 7. So y is -22. Okay? So we have a point. -5 and -22. So by the way, someone else could have picked a different x value and we'll get a different point, right? So there are multiple correct answers to this particular problem we're on right now. Our slope, I hope you can see, is 3. So let's write out point-slope form. Y minus a -22 equals 3 times x minus a -5. And let's just simplify a little bit. Okay, so those two equations represent the same line. They're just in different forms. Let's go in reverse. So let's take a line in point-slope form and put it into slope-intercept form. The way to do that is to distribute the slope through the parentheses. So we'll get y plus 2 equals 1/5 x minus 6/5. And then let's subtract 2 from both sides. So we get y equals 1/5 x minus, so then 6/5 minus an additional 2, so minus an additional 10/5 is minus 16/5. I suppose you could keep it in fractional form if you wanted. You could turn them into decimals if you wanted as well. All right, so that was an example of going from point-slope form into slope-intercept form. So nice, good job. That's a good place to stop.